the mixed pixel technique, there is one important technique is called the spectral unmixing, and linear spectral unmixing technique is the most commonly used technique to unmix the spectral mixture within a single pixel. So, what is support spectral angle mapper? Spectral angle mapper is a very common classification technique in hyperspectral remote sensing images, and it is a very intelligent technique. So, spectral angle mapper is a physically based spectral classification technique. It's a physically based spectral classification technique where spectral similarity between two spectra are determined by calculating an n-dimensional angular measurement between the spectra. So, it is such a technique where spectral similarities between two spectra are determined by calculating an n-dimensional angular measurement between the spectra. The spectra of individual pixel are calculated as vector in n-dimensional space, where n is the number of band. So here, suppose this is a band and this is another band, and this should be y, and this is the x. So this is n-dimensional feature space, and here two spectra will be matched. So for matching these two spectra, an n-dimensional spectral angle has been calculated over here. So this is the spectral angle, that is one spectra and that is one spectra, and it is very pertinent in this case that this spectra will have a direction and magnitude, and this direction will show you the spectral property of any pixel or of any feature. So in this case, to determine the spectral similarities, here a n-dimensional angular measurement between the spectra can be determined, and the spectra of individual pixel are considered as the vector in n-dimensional space, where n is the number of band, and each vector has certain length and direction. Each vector has certain, that is a vector and this is a vector, and these two vectors has a certain length and direction, and the length of the vector represents the brightness of the pixel, while the direction represents the spectral feature of the pixel, and greater the length, greater will be the brightness. Length will determine the brightness of the pixel. Greater the length and greater will be the brightness, and direction will represent the spectral feature. Okay, if it is directed towards this way, then the spectral feature will be anything rather than that. Okay, and as the angle is so acute, then there will be the spectral similarity. If this angle is like this, then the angle will be acute between these two spectra, and then you can say the spectra are so similar. And if the angles are so wider in nature, if the angle is like that, then you can say the spectra are quite dissimilar. So it is the basic thing of this kind of spectral angle mapper, and the spectral angle values will be in between of 0 to pi by 2. Okay, so this is the spectral angle mapper. Now the next will be the support vector machine. Support vector machine is the most modern classification technique. And it is very important thing, and it is very important thing, and it is very noteworthy as well that these kind of classification techniques you can also use in case of the multispectral. So support vector machine is a non-parametric classification system, and it is based on the statistical information of the remote sensing images. It is a non-parametric classification system, and it is based on the statistical information of the remote sensing images. These classification technique separates classes by locating hyperplane between two classes. This classification technique separates the classes using hyperplane or locating hyperplane between two classes. The data points that are closest to the hyperplane are called the support vectors. So, suppose in this case, this is a class and this is another class, or this is a cluster and this is another cluster, and these two clusters are separated using some hyperplane. These are the hyperplane, and this is the optimum hyperplane. Why it is optimal hyperplane? Because this hyperplane is located at a equal distance from these two classes. Okay, so, and these are the pixels or the vector which are closest to these kind of the hyperplanes, and so these pixels are called as the support vectors. Okay, so this SVM or the support vector machine is advantageous in the presence of heterogeneous classes. This is very much ideal for solving the heterogeneous classes for which only few training samples are available, and this is such a classification which has been developed for solving the binary classification problem. Okay, so number one, it is very much advantageous for the heterogeneous classes, and it is very much advantageous for the binary classification problem. Okay, so that is the support vector machine. Next one is very interesting, which is called the multi-layer perception with backpropagation neural network, and you can say it as the artificial neural network, and it is like the artificial neural network. And this kind of technique is very usable or very much useful for the machine learning technique, okay, or the deep learning technique. So this is most widely used. This is the most widely used neural network model with a backpropagation learning algorithm. Okay, so it is a solution. So it is a solution to the problem of training multi-layer perception, where there is a multi-layer training system. Means suppose within a satellite images there are multiple amount of the features, and those multiple amount of the features are so closely confined that a simple training site generation cannot identify each and every pixel having different type of the natures. So in that case, this kind of backpropagation neural networks is the technique is very important or very essential and very fruitful. So it is a solution to problem of training multi-layer perceptions. And this is the most ideal classifier to generate complex decision boundaries in feature space. I just want to say one thing, that to generate a complex decision boundary in case of the multispectral images, supervised parallelopiped is very important. Supervised parallelopiped is very important in case of the multispectral images where the complex decision boundary is very much needed. But in case of the hyperspectral remote sensing classification technique, this kind of backpropagation neural network is very ideal to generate the complex decision boundaries in the feature space. It can approximate Bayesian posterior probability at its input. It is very much ideal, or it is very much ideal to approximate Bayesian posterior